Okay, so adding and subtracting fractions, you need a common denominator. So for example, I won't even do these ones on the bottom, but like draw a circle and cut it in half. Draw another circle and cut it into thirds. It's like a peace sign. Like they're different sizes. This is like a grade 7 lesson. They're different size cuts, so you can't add them. You have to have a common cut, a common denominator. It's a common size cut. So for 2 and 3 in the denominator, like 1/2 and 1/3, what's the multiple that 2 and 3 both go to? 6. So you have to cut it into sixths. So you'd have to cut this half into 3 parts. And you'd still shade in the half. And you can see that it's 3 out of 6, right? 3 out of 6. And then the third, you'd have to, how do you make that into 6? You'd have to cut the third into halves. And the third, let me just back it up. The third was like one part of the peace sign, so we cut that into halves on the thirds. You can see that this becomes 2 out of 6. Now you can finally take your 3 out of 6 and 2 out of 6 and do the adding or subtracting. So if you subtract, what would you have? 1 out of 6. And if you added, you'd have 5 out of 6. So it's no different than like 3x plus a 2x is a 5x. Right? 3/6 plus 2/6 is 5/6. Just an object, right? Okay. So what was the pattern here? What was the pattern here? What do we do to the 2? We times it by 3. What do we do to the 3? We times it by 2. Okay, so let's do some of these quickly. Times this by 5, times this by 3. Whatever you do to the bottom, you do to the top. So you got 10 over 15 plus 6 over 15. This is 16/15. So apparently 2/3 plus 2/5 is greater than 1 whole. Apparently. Right? You can estimate this to like 0.666 plus 0.4. Yeah, it's going to be just over a whole. You guys good on the grade 7 lesson? The multiplying or adding and subtracting fractions. So when we go to the rational expressions, you just make sure they have the same common denominator, and then we're going to give that a shortcut of LCD. Okay, so lowest common denominator. So looking at the first one, what's the lowest common denominator for 4, 5, and 10? So what you're thinking about here is what's the lowest common multiple for 4, 5, and 10. And a lot of people, when they're first doing this, you might make some lists like 4, 8, oops, too much. 4, 8, 12, 16, 20. Why did I stop at 20, Mahad? Because 5 could also get to 20, and so could 10, right? So I need to get to 20. So I times this one by 5, I times this one by 5. I times this one by 4, I times this one by 4, and I times this one by 2, and I times this one by 2. Whatever you do to the top, you do to the bottom. Why? Yeah, it's equivalent fraction. Good. So you get 15x over 20. And we're going to add 4x over 20. And then we're going to subtract 14x over 20. So altogether, you have 19x minus 14x. You have 5x over 20. And of course, this is that situation where I'd ask you to highlight the coefficient on the monomial. You see the 5 over 20? So 5 over 20, if you're not good at reducing fractions, you can go 5 divided by 20, math fraction in your calculator, right? So you can see that 5 and 20 have a common factor. What is it? 5. Good. So 5 divided by 5, 1x. 20 divided by 5, 4. So the final answer is x over 4. Is there a non-permissible value? Is this denominator ever 0? Or is it always 4? Okay, so there's no NPV there. Next one. The 3 and 6. So a lot of people, like especially my kid, when I was teaching him fractions, he'd be like, okay, well I can just go 3 by 6 is 18, so 18 will be my lowest common denominator. Is he right? So 18 is a common multiple, but it's not the lowest. right? All you'd have to do is take 3 to 6, right? So just times this by 2 and times this by 2, right? And then they'll both have 6 in the bottom. So the second one we're not even going to touch. And in the first one, like, what's special about the numerator? Like, what operation you got to be careful about here? You have to, starts with this. Yeah, you got to what? Distribute. So we got 6a minus 2 all over 6. And once you have the fact that they both have the same denominator, what do you do with the tops? You combine them, right? Combine the tops. So how many a's do you have? And the number would be -2 and a +5. What do they combine for? +3 all over 6. Let's try to reduce. Any common factors for 10, 3, and 6? Nothing, right? What kind of number is 3? Prime. There's only 3 and 1. So 3 will work on 6, but does 3 work on 10? No, so you're done. And is there any NPVs? No, because 6 is always 6. Next. Now this is where it gets dicey. Put a big fat star on this, and this is the most common mistake in the unit right here. This one right here. And it's when you subtract parentheses. Parentheses. When you subtract parentheses, you are likely going to make a mistake. It's just probability, just from my experience. There are at least probably 10 of you that will make this mistake. It sucks. I tell kids every year, please don't do this, but it still happens. So let's check it out. Before we get there, LCM, 8 and 3. Count by 8s, count by 3s. When do they match? 24? Is there a better one? 18? Nope. It's got to be 24, right? 16 wouldn't work, right? Yeah, so you see how what's the strategy there? Start with the bigger number, 8, 16. So 16, does 3 go to 16? No. 24, does 3 go to 24? Yeah. Okay, so what do we times each by? And this is that one where my kid, if I'm teaching, he gets this one right every time, because like, when in doubt, just times these two, because that will work. The only problem is you might have extra simplification after. In this case, you won't. Times 8, times 8. Times 3, times 3. Okay, don't forget to distribute. Don't forget to distribute. I put distribute. That's kind of funny. Distribute. Okay, and then times the top by 3, you got 24y minus 9 all over 24. Everyone okay with that? Minusing. Distributing this 8, we got 16y plus 8 all over 24. Now, this is where the common mistake comes into play. It's right here. You're subtracting that whole numerator. So there's these like invisible brackets. Invisibrackets. Is that a word? Invisibrackets. Google it. I invented it. Just kidding. So you have to subtract the whole thing. So what happens to both terms? They switch signs. Good. All over 24. So this is what the goal is. So what's the structure? Get the LCM. Once you have the LCM, combine the tops. If it's plus, it's easy. If it's minus, be careful. Get the LCM. Combine the tops. If it's plus, it's easy. If it's minus, be careful. That's not the final answer. What is the final answer? 24 minus 16? 8y minus 9 minus 8? Negative 9, negative 8? Negative 17 all over 24. What kind of number is 17? Prime. So the only factors are 1 and 17. Does 8 and 24 work? You're done. Is there an NPV? No, you're done. Next. Yep. Okay, class example 3. I mean, it's the same stuff, just harder. I just want to do these ones first. Well, if we have time, we'll go back to class example 3. Okay, class example 4. Class example 4, what do you notice about every single question? Same denominator. So, what do you do when you have the same LCD? What's the next step? Combine what? Combine the tops. And tops is code for numerator. I just don't have the energy to write numerator. Okay, so first one, 2 plus 7 minus 1, 8 over x, comma. Is there an NPV for that first one? What is it? 0. Good. Why? Ashwin, why? It's obvious, right? It's too obvious for you. What about Kausar? Why is x not allowed to be 0? What if x was 0? 8 divided by 0. Type 8 divided by 0 in your calculator. Type it. What do you get? What does it say? Type it. 8 divided by 0. Enter. What does it say? Math error. Okay, it's undefined, right? So when x is 0, this is undefined, so x is not allowed to be 0. A hint, mono with variable. Okay, that's the hint. That's when you know x can't be 0. Oh, I heard a sigh of disgrace. He's upset. Okay, second one. Once you have the LCD, what do? Combine the tops. If it's plus, it's easy. So 5a plus a, 6a. 3 plus minus 6, minus 3. All over 2a. Am I done? There's an NPV, sure, but is there something else I could do? Three's prime. What's the factors of 3? 1 and 3. So nothing will cancel, but you still could do some work in the top to make it cuter. What could you do? Take out a 3, and you get 2a minus 1 all over 2a. You're right. Nothing canceled, but you can still make it look cuter. Comma, a is not allowed to be 0. Good. Next one, subtraction. Hard. Only if this is a binomial. If the second term that you're subtracting is a binomial, it's hard. So, in fact, this one's not hard. This one's hard. The second one's easy. C is easy, actually. So what's, just combine the tops. What's it going to be? 3y minus 1 all over 3y minus 1. What's this? 1 over 1, which is just 1. As long as what? As long as y is not. This is Jolene's turn. Cover up the 3. What would make it work? Cover up the 3. What is it? Let Jolene do it. 1 what? 1 what? 1/3. Very nice, Jolene. She's got it. You got it. You're just maybe a little bit nervous. Next one. LCD's already there. So we know it's going to be x plus 3 in the bottom. What goes in the top? 4x plus 10 in a bracket minus 2x plus 4 in a bracket. This is where it gets dicey and I lose some of you. This hard style of question here. Okay? Because you have to think to yourself, okay, this negative is being distributed onto both terms. I'm subtracting that whole entity. I'm subtracting that whole parentheses. I'm subtracting, what's another word for bracket? Okay, so what's this going to be? 4x minus 2x. Positive 10 minus 4. All over x plus 3. Keep it going. What do you got? 2x minus 6 over x plus 3. Am I done? I put minus 6 by accident. Thank you. Am I done? Ashwin, what can I do? GCF, what's the value? 2. Very nice. And then, lo and behold, what happens here? This is going to cancel. You're left with 2. Good, Jacqueline. So no matter what value you pick for this ridiculous equation or expression up here, no matter what value you pick, you're always going to get 2. I challenge you to type all this junk into your y1 and watch. Just 2 everywhere. For every x, it's just 2. You know those horizontal lines that cut across when you're on your calculator? So no matter what x you pick, you always get 2, except for 1. Which one? X is not allowed to be -3. So what would this look like on your graph? It would look like this. Bloop. When x is -3, you get a hole. That's what it is. It's a hole. And they call it a point discontinuity. You see that later in Math 30 and Calculus. This is a hole. Point discontinuity. So it's continuous everywhere except for this hole. It's like a black hole. Bathroom? Okay. All right. Class example 5. Do we have the same LCD? No. And there's variables involved. So think about the similarities and the differences.
Mr. Newsom, please contact the office. Mr. Newsom, contact the office, please.
Okay, just looking at the denominators. What's similar and what's different? P is similar and numbers are different. So we already have the P taken care of. We just need to adjust 3 and 7. First number that 3 and 7 both multiply to. Darn that one. Times by 7, times by 7, times by 3, times by 3. What do you get? 35 over 21p plus 6 over 21p. What do you got here? 41 over 21p. Does 41 and 21 reduce? No. If it was 42, yeah, but it's not. It's 41. Comma, what's p not allowed to be? 0. Good. Next one. 3y and 5. What's similar? Nothing. Nothing is similar. So do the easy parts first. What's 3 and 5 going to go to? 15. And what does this guy need? It's like you go to the mall, and that day at school you saw your buddy had a nice pair of shoes. You're like, I had to have those. You go and pick up the same shoes. You're like, I had to. I had to have those shoes. They just look so fly, right? Yeah, so that's basically what's happening here. You need to put a, whoa, sorry, Mike, oh my gosh, I know, we're having some, okay, what's happening? Okay, we're back, sorry, my iPad just had a little glitch. Okay, so, we're going to times this by 5, we're going to times this by 5. So then, what will it be over here? 5 over 15y. So what do we need to put here and here? 3y, good. 3y, good. So what do you have there? 18y over 15y. They have the same bottom, so we can combine the tops. 18y plus 5 all over 15y. Are we done? Y can't be. Is there a GCF for 5 and 18? No. Y cannot be 0. Good. Next. Ooh, 6x and 3x. This is pretty easy. Should I go to 18x squared? You'd want to, right, Joel? Just create more havoc than you need to? Yeah. What about you, Freddy boy? What would you do? Nothing? Just sit there? Observe. I like it. How to make 3 look like 6? Just double it up, right? And is x already x? So ask yourself, what's similar? What's different? What's similar? X and x are similar. What's different? 3 and 6. So what do I need to do to the right denominator? Times by 2, times by 2. What do we have? 2x minus 5 over 6x. Didn't even touch that. Over here we must distribute. We have 6x minus 4 over 6x. Now this is the scariest question. Why? What are we doing? Subtracting parentheses. Very nice. So another star. Subtract a binomial. Be careful. Be careful, be careful, be careful. We have a star. We have a highlight. Be careful. So we have 2x minus 5 minus 6x plus 4. This is the most, especially if minus minus becomes plus. Oh man, do I lose a few of you. For sure. All over the LCD, which is 6x. So now it's just like terms. Like, yeah, like terms, right? Is that what you call it? Okay, 2 minus 6, what is that? Minus 4x. And then minus 5 plus 4, what do you got? Minus 1, all over 6x. I'm done except for the NPV, x can't be 0. And you guys watched the Oilers game last night? Oh yeah. How about that Connor McDavid, eh? He's aight. Yeah. Did you guys know that the Oilers are in first place and Connor McDavid is at the top of the scoring race right now? Hey, the Leafs are going to be good too. You wait, Oilers Leafs Stanley Cup final. Dowd's sitting there right now like, what's hockey? Okay, let's look at the next one. A little bit more challenging because is there anything similar? A2, A1, 2 and 5. So we got to adjust both. 2 and 5, where are they going to meet? 10. And where's A2 and A1 going to meet? Yeah, good. A2. So what do I need to multiply the second guy by? 2A on top and bottom. Good. And on the left guy, what do I got to do? Just 5? Yeah. So we have a 5A plus 35 after distributing. And over on the right, we have a 6A. All over the LCM, which is 10A2. So, is this one tough? Subtracting a monomial? No, you just make sure that you go 5 minus 6 is negative A plus 35 all over 10A squared. And then, like, even this, like this last step, completely optional, but I've told you in the past, like, if you see a negative lead coefficient, like, maybe take it out. That's just good habits. That's just good habits. So this last step, optional, but it's a good habit. It's a good habit. A not allowed to be 0. Are we done? Okay, now we get into the binomials. So when there's binomials involved, it's actually easier. It's actually easier. So let me check out, we'll just do B first. This is actually easier. So remember the whole thing, like if you see your buddy's shoes and you're like, I gotta get those shoes, and you copy it? So it's like, what does this guy have that I don't have? What does this guy have that I don't have? Yeah, it's just like exchanging, they're just exchanging each other. So it's like, times this one by 2y plus 5 times this one by 2y plus 5. Times this one by y minus 3 times this one by y minus 3. And then what do you notice now? Once you've done that, what do they have that's the same? Their LCD is the same. They have a lowest common denominator. That's now the same. So what I like to do with these questions is actually just edit the question itself. I wouldn't rewrite it. Just edit it right on the page. It saves you time and space. And now, once they have the same LCD, what can you do? Combine the tops. So we have a y minus 3 with a 4 in front, and we're going to subtract a 1, 2y plus 5. All over, and you know I'm lazy. I'll just put LCD, because I'm lazy. I got work to do in the top, but I'm lazy. Distribute the tops, what do I got? 4y minus 12, distribute the minus 1, I got minus 2y minus 5. I'm still lazy all over LCD. Keep going. I'm just lazy. 4y minus 2y, 2y. Negative 12, negative 5, negative 17. And I'm done with the top. So now I'll quit being lazy and I'll put in my LCD. And then don't forget, of course, y is not allowed to be 3. And Jolene, cover up the 2. What is it? Negative 5 over. Very nice, Jolene. You got this. Okay. So I'm going to leave this one right next to the one for C. And let's see if we can copy the steps. We'll go slower on this one. Don't worry about that graphing calculator. They're only like over $100. Okay, what was the first thing I did over here? What was I doing here? So I got to do it over here. LCD. And did I like write the question out or did I just edit the question? Okay, so what does the x plus 1 need? Yeah, it's like, well, what do you got? I want that too, right? You know, it's like a jealousy game. What does the x minus 5 need? X plus 1 and x plus 1. Like when I was growing up, it was like, oh, you got the Genesis? Oh, I only got the Super Nintendo, you know? I always like, I go over to my buddy's house, he's got the Genesis, and I'm like, oh, man, I only got the Super Nintendo, you know? Yeah, the Super Nintendo had its perks, but the Genesis had Mortal Kombat Blood Code. Okay, now, what I want you to realize is that basically what you have is numerator 1, plus or minus whatever it is, numerator 2, all over the LCD. That's basically what's happening here. So where's numerator 1? And what is numerator 1? It's all this, right? And what's numerator 2? It's all this. And then what are we going to put it all over? All this. But you only do it once, right? The LCD is just once. So what's numerator 1? We're going to have to distribute this. Oh my gosh. Right? So this is maybe like off on the side. You do some scratch work. Okay, so 2x squared plus x plus 2x is 3x. And then the last one is a 1. And are we plussing or are we minusing? We're minusing, right? Now let's do the second one. And again, maybe you do some work off on the side if you can't FOIL in your head. So x times x is x squared. Minus 4 and minus 5 make minus 9. And then minus 4 and minus 5 make positive 20. All over LCD because I'm lazy. And again, this one has the negative in front of parentheses. So it's more challenging in some respect. So be sure to distribute that negative. Now, we know it's like terms, and they're in order. So check this out. 2 minus 1. Yeah, 1x squared. Try the next one. 3 minus 9. And I love to say it like vocally. If you verbalize it, you have a better chance. So like I'd be in my test going like 3 minus 9. Like I would double up that minus in my head. So 3 minus is so it's good. It's good. So plus a 12x. 3 plus 9. And then we have a plus 1. So 1 minus 20. 1 minus 20, negative 19. Oh, 3 minus 9 is 3 plus 9 is 12. All over LCD. Do I write LCD or am I done here? Looks like I'm done. I can't do anything more to the top. So now I'll quit being lazy and I'll jot in the LCD. Now sometimes this thing up top could be factored. 19 is prime. So the only factors that would work are 1 and 19. Are that ever going to add up to 12? No, so done. Except for what? X can't be. Jolene, you with us? What's this one? And? Positive 5, right? Ah, we're making Jolene work hard today. She's going to be YouTube famous. Yo. I got like 4 views on my last video, so. You guys, you hear me breathing? Luke. Mahad, it's hard work up here, okay? Give me a break, jeez. Okay. Oh, because I was on that, this thing was dead. Okay, the first one we skipped because it's a little bit different. If you look at these two, it's a binomial with a binomial. Over here, what do you have? A binomial with a monomial. So again, it's a little bit of the same. Like, what does this one need that this one doesn't have? X minus 4, X minus 4. And the one over here, McKenna, 2X and 2X, right? Okay, so you have numerator 1. X squared minus 13x plus 36. I mean, you guys have factored so many polynomials in your life that you should know that right off the hop. Minus 4, minus 9, minus 13. And they multiply to plus 36. And we're plussing, so it's easy. We're plussing 6x. All over the LCD, 2x, x minus 4. Okay, so the only like term is here. Negative 13 and a positive 6, negative 7x plus a 36 all over the LCD. I wasn't lazy here for some reason. Comma, x not allowed to be. Jolene, you ready? This one? Beautiful, and look at you. 0, comma 4. Yeah. That's like when you go on a date, you're like, do you know I can do NPVs? Did you know? She's like, wow, I'm so into that. Come pick me up, this guy's a math nerd. She's texting back, but he'll be rich. Okay, next one. Okay, what do you notice about this one? Instead of there being 2, there's 3. So now it's like when there's 3 friends, and one of them's got like the new Air Jordans, the other one's got some like Skechers, and the other one's got I don't know, Dockers or something. And everyone's like, ooh, I want the Jordans, but I kind of want those Skechers. And then that's like, yeah, but I gotta have those Dockers, right? So check it out. This one needs the x plus 1 and the x plus 2, right? So copy it on top and bottom. Gotta have those Dockers, gotta have those Skechers. And then the x plus 2, what does he need? He needs the x plus 1 and the x. So copy top and bottom. And notice I'm editing right on top of the question because it's annoying otherwise. It's super annoying. And I've run out of room, so bear with me. We got an x and x plus 2, and we need an x and x plus 2. Okay. So let's do the first one. 3x is going to multiply in and distribute. We got 3x squared plus 3x. Okay. And remember, this is all over the LCD. Remember the structure. Numerators plus numerators plus numerators all over LCD. So what's the second one going to look like? 2x going to multiply in, and we get, and there's a minus here, so I like to keep the structure, keep it very neat and tidy. 2x squared plus 4x, right? And then we have a plus. Keep it neat and tidy. This last one is dicey, but it's just basic expansion. 2 plus 1 is 3, right? And 2 times 1 is 2, and x times x is x squared. All over LCD, I'm lazy. Now, with this organization, you know, the first part looks pretty unorganized, but the second part is very organized, and it helps me with my like terms. So we have a 3x squared, a minus a 2x squared, and a plus a 1x squared. 2x squared, good, Joel. And then, now let's jump into the x's. A plus 3, minus a 4, and then a plus a 3. So it's like 6 minus 4 is a 2x. Now the constants, we have nothing, nothing, and plus 2. All over LCD. Take out a 2, you got x squared plus x plus 1. That's a 2. Can you guys factor this second piece? What multiplies to 1? 1 times 1. So it would have to add up to 2, right? So it can't be factored. So I'm done with it. All over the LCD, x plus 1, x plus 2, comma, x is not allowed to be 0, negative 1, negative 2. Thank you for being patient. That's it. Do lots of homework tonight. And I've done enough that you should be okay to do the quiz tomorrow. Do some homework tonight. Lots and lots of practice will make you better. Stay at East if you want more time to work. Have a great life. I have to stop the video and then I'll see you.